Good morning, everyone. How are you doing on this beautiful Saturday morning? Little dreary, but I think UVA is going to win today. Wahoo wah! Anybody else agree with me? Got to send out those positive thoughts in advance. I'm Althea Brooks, and I'm Director of Lifetime Learning here at the Office of Engagement at UVA, and it's my pleasure to welcome you once again to More Than the Score. How many of you really, really like this program? You have made my day, my week, my month, so thank you for being here. More Than the Score provides you a faculty member each Saturday morning before the home football game, and we partner with the Alumni Association in offering this program, and it really is my pleasure each spring to search through the list of faculty members and find a great speaker for each of those Saturday mornings. So again, thank you for being here. We have Stephen Macko, Professor Stephen Macko from the Environmental Sciences Department, and want to just make him feel really welcome before we even introduce him. So go ahead and give him a round of applause. If you have a cell phone, we ask that you go ahead and silence the ringer on that phone. We also are recording this morning's lecture. It'll be made available on the iTunes U site as well as the More Than the Score site. So feel free to download or listen to that on the iTunes site. If you will, go ahead and sit back and relax. I'm going to introduce Professor Steve Macko really quickly. I want to give him the full hour so he could share all his wealth of knowledge with you. Stephen Macko is Professor of Isotope and Organic Geochemistry in the Department of Environmental Sciences at the University of Virginia. He received his undergraduate degree in chemistry from Carnegie Mellon University and his Master of Science in Oceanography from the University of Maine. And in addition, he received his PhD from the University of Texas in chemistry. As a scientist or chief scientist on numerous ocean expeditions, Professor Macko has dived to depths of over 500 meters in submersible Johnson Sea Link and 5 legs of the ocean drilling program. He has authored over 250 referred research papers and books. At UVA, Professor Macko teaches classes in oceanography and geochemistry, and he's received the All-University Teaching Award at UVA and was finalist for the State of Virginia Faculty of the Year Award. In addition, Professor Macko received the Outstanding Faculty Award from the Lifetime Learning Program in the Office of Engagement in 2011. He recently held the position of Program Officer for Geobiology and the Low Temperature Geochemistry at the U.S. National Science Foundation. Professor Macko's laboratory has been featured on the Discovery and the National Geographic television programs, as well as in The King Corn, a documentary that looks at the influences of corn on the lives of North Americans. This also appeared on the PBS stations. Please help me welcome Professor Macko this morning as our More Than the Score speaker. Steve, come on up.
Thank you. Thank you for coming today. Before I start, I really wanted a person that should be recognized for organizing all this is Althea, because she's been doing so much for the Office of Engagement with alums, so I want to say thank you. My plan today is to address what some would call a crisis. I'm going to present information to you, and I'm going to let you be the judge as we go through, and you decide how large is this crisis that could be looming for the ocean. And as part of that, we're going to look at this planet. The planet, if you think about the Earth has an ocean, and we think of the ocean as being very deep, but if I held a globe in front of you, and you look at the globe, the thickness of the ocean on that globe is about the thickness of the paper on the skin of the globe, okay? But that water covers 71% of the Earth's surface, and it is because of that water that life exists on the planet, and it is the only place that we know at present where life could exist. Okay? And so consider that as we go through this. Consideration at the same time is that we have this very growing population on the planet, and this population is now at the highest. I mean, it's, we've got 7 billion people, and it's going to continue to grow. We depend on the ocean for nutrition, for energy, for mineral resources, and also for pleasure. I'm going to give you information, you be the jury, about what the status of the ocean is. The things that we're going to look at, I'm going to tell you a little bit about the basics on the change in state that we're seeing going on with this thin veneer of water on the surface. And we're going to look a little bit at something that I know a lot of you have heard and read about, and that's that the Earth is warming and that sea level is rising. We're going to then also talk about the idea that there will be a loss of sea ice. That's going to affect productivity on the ocean, how many fish that we can get from the ocean, how life is sustained in the ocean. We're going to talk a little bit about pollution, something that I'm going to talk with you a little bit about a type of pollution you may not even be considering, and this last one, that the ocean is becoming more acid. Some people call this the other carbon problem. And some of the other impacts of the changing ocean as far as migratory birds, how they're being affected, the fisheries in general, and other kinds of pollutants that you probably are aware of with regard to oil and the large oil spill from the BP disaster, as well as other metals that are in the ocean that you should be aware of if you're not. There is strong evidence. Make no mistake about it. The Earth is warming. Okay? We can discuss why it's warming. We can argue about that, how much impact humans have, but the Earth is warming. The temperatures are increasing. They're at the highest level of any recent documentation, and they will continue to increase. The models suggest that over the course of the next number of decades, over the next century, that we're going to see temperatures that are on the order of a few degrees warmer than at present. How will that impact whatever's happening on the face of the Earth? It's going to change the way we think of the Earth today. There are suspects, and we can talk about this. I'm mentioning this simply because one of the changes with these suspects is going to be the result of the ocean changing, the ocean warming, that you may not realize it. The suspects for helping to enhance the warming under the models are carbon dioxide, obviously, but methane. You may not think about methane as being related to the warming of the Earth, but in fact it is. For every molecule of carbon dioxide, the models say we're going to see so much warming going on as the carbon dioxide resides in the atmosphere. Methane is released also. Methane has 20 times the warming capacity as carbon dioxide. So most of the emissions are coming from the developed world, and the big giants are China and the United States, realizing, of course, that China's population is far greater than the United States. And on a per capita basis, and the developed world leads, and the United States, because of the size of its population, is the leader. There are regions of the planet that are going to be susceptible to or vulnerable to this change most immediately. And you've seen maps like this, and I'm sure that you've seen pictures of some places like South Florida will be underwater. New Orleans, which is already underwater, will continue to be further under sea level. But places like Bangladesh, the coast of Holland and England, China has large areas, and there will be hundreds of millions of people being affected by the rise in sea level. This is the rise in the ocean surface. We're talking about meters, the height of this room perhaps. and over the course of the next century. Something that I'm going to emphasize more that you probably haven't thought much about, and really few scientists have, is that as the Earth warms, it's going to impact the Arctic much greater and the Antarctic much greater than we see in the more temperate latitudes. And that's because the Arctic and Antarctic are under ice. And this is coming from one of my expeditions, and this is called the Lead. And at the present time, the Arctic is changing more rapidly than at any time in the past at least 10,000 years. It's warming. The Arctic surface is being inundated, and this is all you can see the coastline there. All of this is going to be underwater in the near term. And you think, well, why do we worry about that? Well, it turns out that these areas are breeding grounds for huge populations of birds. There are birds that migrate from South America all the way up to the high Arctic to breed, and their breeding grounds are going to be underwater. The Arctic is especially sensitive because it is under ice, and a lot of that sunlight, a lot of that energy is being reflected back into space. But as the ice melts, the Arctic Ocean is going to be exposed. It's going to be darker, and more heat is going to be absorbed. So it's going to be an accelerated warming. And in fact, the Arctic is presumed to be that it's going to change by the order of many degrees, not 3 degrees, but maybe 10 degrees warmer than it is at the present time. The Arctic is covered by sea ice every year, and there's a time of melting going on. At the present time, well, this was the chart that I used last time I talked to my oceanography class last spring, and I said 2007 was the lowest point on sea ice ever recorded. Well, I have to change that, because in 2012, we are now at a minimum for sea ice coverage that has ever been recorded this September. A lot of the things, I was telling Althea that some of the things you're going to see yesterday's newspaper, and a lot of things are happening, and they're happening very fast. But why do we worry about sea ice? I'm going to come back to that, because it has something to do with fisheries, productivity, bird populations, and others. But what we're talking about is that parts of the Arctic are going to be open water for a greater part of the time. In fact, there have been ships that have now gone across the Arctic without the help of icebreakers. That's for the first time in basically recorded history. The changes influenced by rising sea level. Some of the changes of warming are going to be obvious. You know, what we're going to see, and I took part in a conference up in Seward, Alaska, and part of that conference, they had a lot of lawyers there, and we're talking about, well, this is who is going to own all the minerals, the resources. The Arctic has hydrocarbons, probably a lot of natural gas that's going to be available for exploration. And so we're going to be able to look for them. We, in fact, are looking for it. Shell had a rig this past summer that was beginning to explore for hydrocarbons in the high Arctic. There are going to be increased avenues. You know, people are going to be able to cut off a lot of cost from going from the Atlantic Ocean to the Pacific Ocean if the Arctic is open. So these are economics. There's going to be increased tourism. You know, perhaps you will be, over the course of the next few years, on some ocean vessel that will go across the high Arctic, and you'll be going as close to the pole on open water as they could get. But some of the effects are going to be less obvious. The ecosystem is going to be changing. There is going to be effects of us exploring for oil. There is going to be effects on the fisheries as we open up the Arctic with less sea ice. Something that is kind of interesting is that, and this is at the present time, this is the coastline of Alaska, and what you're seeing is erosion of peats. That because it's now open water more, because it's warming, there is actually meters, sometimes per day, of the coastline that's eroding into the ocean because of the warming. And you think, well, you know, this has happened, we get erosion all the time. But in those peats and in the permafrost are basically frozen methane, okay? Frozen methane, we call those hydrates, gas hydrates. This is one that when I was 500 meters below the surface off the Gulf of Mexico that we actually saw for the first time these they're called gas hydrates, in the seabed off of the Gulf of Mexico. That's methane's coming up along with the oil, and because of the pressure and the temperature, it actually forms a solid structure. And so we discovered that. There was a form of life that we discovered at the same time. That's another story. But these peats have a lot of these gas hydrates in them, and some people have suggested that they're going to be a source of energy for future generations. And these are some students, actually. You can hold them in your hand. They feel they're about 5 degrees centigrade, but you can actually ignite them. And so they're just a little bit of a problem on how to handle them because they're not stable. The Arctic has 400 gigatons of natural gas that's in the form of this gas hydrate. Well, what's happening with the ocean, they have these gas hydrates, and as the ocean is beginning to warm, they're becoming less stable. 5 degrees is kind of their limit of stability. And what's already happening off of Svalbard Island and other parts of the high Arctic, that these are recordings of the bubbles that are coming out of the sediment, and methane is going into the ocean and escaping and going into the atmosphere with this enhanced warming capacity of 20 times carbon dioxide because of the destruction of the gas hydrates. Okay, this is physical chemistry. It's happening at the present time. The curious part, and most Canadians, and so since I was talking up in Seward, there were some Canadian scientists there and lawyers, that Canada is going to be one of the larger producers of methane to the atmosphere because of their large amounts of gas hydrates that are in the peats. They don't realize that. So, and what are the gas hydrates dissolving in the water going to do? Well, in fact, they're going to have these warming effects, but they're going to affect fisheries. Fish are going to avoid high levels of methane. They can't breathe. So, I'm talking about fisheries. How are the fisheries being affected, or how will they be affected as we get global change going on? I'm putting this as a little plug that if some of you live around Charlottesville, that during January term I actually run a course called The Captive Ocean, in which we talk about sustainable fisheries. And these are some of the UVA students visiting some of the aquaria. Last January we actually went below the Baltimore Aquarium, which is kind of, you think about 10 million gallons of water on top of you. But we run that in January, addressing the issues of sustainability. But I want you to consider the ocean is the last place where we harvest the wild protein. Okay, 1/6 of the world's protein comes from a wild source. That's 1 billion people if you do the average. And we're depending, 1 billion people are dependent entirely on the ocean, in effect, for harvesting that protein. How is that going to be affected? How is it being affected? Well, every time that we've had a wild source of protein, we've mismanaged it, whether it was bison, the halibut, the large halibut, or the tuna populations. Is the open ocean the final frontier? 1/6 of the world's nutrition comes from the ocean. Generally, we see fisheries mismanagement. Globally, there has been overfishing. Globally, there is commercial extinction potential. You know, if I mentioned an organism called the stellar sea cow, has anybody ever heard of the stellar sea cow? 1768, you'd have to be around. That was the last one. It was hunted to extinction. Human-induced extinction of a marine mammal. We've tried it on other things. You've heard of the right whale? There are a couple hundred right whales left in the northern oceans. You think this is an animal very close to extinction. We've thought it and worried about extinction of mammals previously. I don't know if you've ever waded through Moby Dick, but if you go through Moby Dick, you'll see that there is actually some mentions of worry about extinction or removal of marine mammals because of overfishing. They weren't worried about the extinction itself, or worries that you and I might have, but it was worry about the fishery itself, because marine mammals were harvested. There's another mismanagement. It's called bycatch, and bycatch is when you go fishing, like with a trawler, you're going to catch other things besides the fish that you're looking for, the shrimp you're looking for, and probably at least 27 million tons of bycatch is harvested and thrown back into the ocean because it's waste. It's not what you want to catch. 27 million tons. To put you in a perspective, and I'll show you another graph, 27 million metric tons is about 1/3 to 1/4 of all the fish that we catch globally. So that's, you think about it, we're throwing back 25% or greater of all the fish that we catch as waste right now. I'll show you some bycatch. We're targeting smaller species at the lower end of the food chain. We're modifying the way that we fish. Nature is probably one of the two premier journals in the world, and they commonly have articles about the losses of the fisheries. But this is really the description. If you look at fisheries catches over the course of the last few decades, you'll see that from the 40s up through about 1990, there was increasing fisheries because there was increasing boats. We had increasing good technologies. We could harvest more from the ocean, increasing numbers of vessels. But then right around 1990 or so, everything started to go flat. It was not beneficial to put out more boats. And what was happening is right around 1990 through today, it's flatlined. Any doctors in the audience? But it's flatlining. You're worried. And we are harvesting the same number of fish, smaller, fewer species than we were harvesting just back about 1980. We have not increased the poundage, landings of fish, since about 1990. Despite increasing newer technology, we use satellites more. The vessels are still lots of vessels out there, but despite all that, going into deeper water, it's like a perfect storm. They went into the deeper water to get the fish. We're not being any more successful.
Does that include the fisheries, the farming?
I'll get to that. Good question. Bycatch, we're harvesting more bycatch. There are some fisheries, and I'll show you the data, that bycatch, when I talk about it, they are not what we want. If you're in a shrimp fishery, you want the shrimp, you're catching starfish, other fish, skates as part, and crabs. We're not prepared to handle bycatch. When a boat comes in and goes out, they're not prepared. Well, if you catch a grouper in your shrimp nets, well, if we were prepared to handle the grouper, we could have it in the market. But if you're a shrimper, we're not prepared to handle it. I know of one country that actually actively does something with bycatch, and that's Iceland. And I talked to a guy who has worked in Iceland. He said they actually have to document all the bycatch. We don't document it. It goes over the side in the North American fishery. Bycatch could be turtles, okay, dolphins caught in tuna fish. If you ever tuna fishing, if you ever look at a can of tuna, on the side of the can of tuna, it actually says dolphins safe. That has meaning under the laws of the United States that you adhere to attempting to let the tuna out of the tuna fishing nets, those purse seines. And so you're adhering to those. When we import tuna from Mexico, Mexico doesn't have to adhere to the laws of the United States. And so they often don't use dolphin-safe practices. Bycatch could be sharks. Why do we want sharks? Sharks, we think about sharks, we think about Jaws, we think about shark attacks on the beaches of Florida. And in fact, sharks are a very common bycatch in some of the fisheries. And really, who cares? Well, in fact, there was a friend of mine, Ram Myers, okay? Ram started documenting this. What was happening to all the fisheries worldwide? We had the landings, and he said, there was loss 300-fold decline in the sharks that were being accidentally or purposely caught in the Gulf of Mexico. Nobody cared. When you put out 10,000 hooks, okay, so long lines of hooks, and you would catch 24 or more. Look at all the locations, 24 or more sharks being caught out of 24 hooks. At the present time, there are 0 in most of those lines. The shark populations have incredibly declined worldwide, and nobody noticed. In the open ocean, we can talk about the large fish. whether it's tuna fish, billfish, and the sharks. In the Northern Hemisphere, intense fishing is being conducted, and there's lots of standards. Japan, before World War II, harvested 1 million tons of tuna fish. 1 million tons. I just showed you 86 million tons is the total world harvest of fish. 1% or more was just Japan harvesting tuna fish. In 1950, the United States harvested about 1/6 of that. In recent fishing, Spain, of all of the North Atlantic, compared to Spain in 1950, Spain's catch of fish, tuna fish, in 1950 was greater than the entire catch of all countries fishing the North Atlantic. Is there a problem? All fish are actually in decline. If you look at, here's numbers of species being caught, we're harvesting fewer species, and the numbers of fish have reached a maximum somewhere around 1990, and they continue to be in decline worldwide. Nature again. I'm going to tell you a story. I lived in Newfoundland. It wasn't part of my resume, but I was a professor in Newfoundland that's how you say it, by the way. And when I lived in Newfoundland, cod fishery was really big. John Cabot, when he was discovering Newfoundland, this is 1500, wrote in his diary, England would never be hungry because of the codfish. There were so many cod in Newfoundland. This is, the fishermen. Newfoundland, up to 1949, was an independent part of the Commonwealth. They had a flag, and on the flag was this seal. And probably you guys somebody in here learned Latin, and you can see if my translation's right. But if you say this correctly in Latin, it means these gifts I bring. And the gift is a codfish. At the foot of Britannia from Newfoundland was a codfish, the gifts I bring. In 1992, the cod fishery of Newfoundland was closed. There was an unsustainable, perhaps faced on economic extinction of the largest fishery in the North Atlantic because the codfish had been so far over-harvested. I like this picture a lot of a kid, the size of the codfish that they were. But since 1992, fisheries in Newfoundland, there were riots, basically. I was there, and there were riots in the streets of Newfoundland because the fishery was closed, because they were facing it would not be extinction off the planet, but economic extinction. Unsustainable fishing had gone on. What has changed in fisheries worldwide? Well, we've seen declines, sometimes 90% of the numbers of fish that we were catching in those of the different kinds of fish. The sizes, we no longer get the large halibut. They're not there anymore. And we're changing the species. We're no longer harvesting the species that we usually catch. We're going for different species. Some of the bycatch, in fact, is now turning into a principal catch. Dogfish, for example, skate. When Rand published this article originally in Science magazine about some of the fisheries, he actually went through and documented the fisheries for the whole Earth. And if you can, I would say red is lots of fish. That means you put out 100 hooks, and you're going to catch more than 10 fish. Blue is not so good. Blue means you're not catching any. You put out 100 hooks. And I'm going to go through, there's a bunch of slides, about 30. I'm just going to click through and watch the world since 1952. Okay, look for blue. So off of Japan already in 1952, not so good. Off of Australia, it was pretty good. And you can see Indian Ocean. Look how great. Indian Ocean, South Atlantic. This is where he was able to get data from. Look at how the Pacific is going blue. 1960s. Notice the Pacific Ocean already. The Atlantic Ocean is turning blue. The Indian Ocean is turning blue. This means you're putting out 100 hooks. You're not catching a fish. Up to 1980. The world's ocean is blue. There's a book by Sylvia Earle, The Ocean is Blue. You should read it. But this means that we're not catching the fish despite increased fishing efforts today. We have flatlined. Changes in the Pacific, up to 42% declines in the fish that are being caught in the Atlantic and Pacific. What are we catching? Well, we're changing some of the fish that we're catching, but we're landing more of something that we're discarding. When you go and you get wild shrimp, for example, a pound of wild shrimp means that they have thrown away, for every pound that's landed, there are probably 5 pounds that are thrown away of bycatch. Shrimp is a very dirty, nasty bycatch, hazardous shrimping. We have alternatives, and you talked about the shrimp farming. Total worldwide, about 25 to 30% at least of the fish that we catch in our nets is bycatch. Totally mismanaged, unmanaged. The fraction of the fish that are being caught in 1970, the cod, this is Newfoundland, also this is New England, so Maine, and the kinds of fish that we're catching to the present, we're not catching as many, we're turning to other fish, dogfish, small sharks and skates. This was a co-author with the Ram Myers worm. He was actually in the Washington Post on Friday talking about it, and I'm going to come back to that. But the thought is that all the world's fisheries, all the fish that when you go to a restaurant and eat the fish, unless it's farmed, that what all the fish over the next 50 years may be economically extinct. We will change our diet. 1/6 of the world's nutrition comes from the ocean, and we have to make that change. Estimates I've given you, estimates that Ram Myers published, they're probably very conservative. One of the striking ones is that when a fish gets caught on one of these lines, it struggles, a shark comes along and eats it, it's not there when the fisherman brings it up. So those fish that get eaten by sharks on the lines aren't counted. Well, with the declining shark populations, those fish are staying on the lines now. So they were uncounted before, and now they're being counted with the declining population. The fishermen are a lot more efficient. We, in all of these things, make it hard to judge the changing of the fisheries, but at least we can see that they're under dramatic declines, and we should be concerned. What else is going on? Primary production is going to be changing. Primary production is the ocean's plants. 1/2 of the world's oxygen comes from the ocean. These are the plants, the slippery green stuff. When you walk on a rock along the shore, those are the plants. They grow in the ocean. They might look like this. Some of them have shells. Those are called coccolithophores. Some of them grow under the ice of the Arctic. Well, if there's no ice, where are they going to grow? The Arctic Ocean is dependent on these same plants that grow under the ice. This is what they're called. They're called ice algae. About 25% of the nutrition of the Arctic comes from algae that's attached to the ice. It actually gets green slime under the ice. It's going to be gone. Or it's going to bloom. The ice is going to be there, but it's going to be blooming long before the timing of the fish becoming available, because it's going away earlier. The Arctic is still going to be frozen for the foreseeable future, but it's going to be ice-free along the land. The effects on the fisheries and primary producers, we don't know. We can't predict what's going to happen to those. Actually, I know that there are plans in Canada for beginning to harvest more fish up in the high Arctic once it becomes open ocean. How many fish are there? Do you know? We don't know. And we're going to start harvesting them with the same intensity that we over-harvest the rest of the world. Our Antarctic is exactly the same. We can flip the globe around, that the Antarctic is warming. The Antarctic Peninsula has warmed probably at least a degree in the last 50 years. What does that mean? Well, there are organisms, they look like shrimp, they're called krill. Whales that live off of Antarctica eat 1/2 ton of krill a day. The krill have declined. We're affecting all parts of the ecosystem, all organisms, penguins, whales, and the fisheries off of Antarctica are being affected because the krill are declining. How warming and the loss of those are going to affect, we don't know. Will there be alternative organisms? Some people hope that because that could be an increase in, what could be supplying. These are what krill look like. These other populations, what are they going to be eating? We see this already with over-harvesting of whales off of the Pacific. And instead of whales, killer whales, the friendly orcas, they are now turning to other organisms for nutrition, seals, for example. And so the whole food chain, the alternative foods are being changed. Spawning of fish is going to be changed. What are the critical temperatures? Some of them actually need sea ice, okay, and in order to spawn and put their eggs and lay their eggs. The timing of the spawning, as the temperatures change, how will those fisheries? This is worldwide. The location of where we find fish. This is the Arctic cod. In fact, if you eat cod in a restaurant now, it's probably Arctic cod. And this is where it's found globally, where they are today. And this was an article in, I think, 2 days ago in the Washington Post. There's a woman that was here for the Virginia Festival of the Book. Her name's Juliet Alperin. She's written a book called Demon Fish. It's a pretty good book about sharks, if you like sharks. But also, she has written a story about the changing locations of where the fish were. That was in the Washington Post, where they will not be there tomorrow. The population says the temperature's warm, the locations are going to be different. This is a little fish that's found in Antarctica, and it's called this Antarctic silverfish. It actually depends on laying its eggs in the ice. So without the ice presence, where is this fish going to lay its eggs? So we're going to lose that kind of productivity. As the changes happen, and with the krill or with the silverfish, instead of being phytoplankton going through the krill, there will have to be some other pathway, or those fisheries and the higher trophic organisms are going to be lost. What about higher trophic level organisms? This is a favorite picture of mine up in the high Arctic. These are belugas. Some of you may have known a child song, Baby Beluga. Okay, these are the little white whales. And it's like there are huge pods of them. How will they be affected? Well, it's hard to say. We're not hunting them to any extreme. Like seals, walruses, sea lions, how will they be affected? But it's pretty clear. It's early morning, after breakfast. And how will they be affected? Well, with the loss of sea ice, polar bears require ice for hunting, for their sustain. They can only swim so far to hunt seals down. Polar bears are threatened with extinction, and that's certain. With the loss of sea ice, polar bears don't go up to the really high Arctic, so they stay by the land and they go onto the sea ice. Without the sea ice, they won't be able to hunt. Some of you I know are birders, and you might think, well, we've got these bird populations. One of my favorites is the red knot, because it actually, I've been told, and I've been told I was wrong also, but the red coloring actually comes from eating eggs from horseshoe crabs. And many of you have seen horseshoe crabs. If you go out to the eastern shore of Virginia, you'll see horseshoe crabs, and they have horseshoe crab eggs, which are these red. And they come in, and they are about the size of my fist, and then they will eat so many horseshoe crab eggs that they will almost double in weight. And what they're doing is they're stocking up on nutrition as they fly through Virginia and Delaware and Maryland, because they're going to go up to the high Arctic and lay their eggs. That's where they oversummer. Anyway, red knots are in severe decline. 100 different species, millions of shorebirds are going to be affected by that coastal change. And it could be that millions of birds, millions of shorebirds are going to be in severe decline. And some people suspect birds like the red knot already are, because of the changing climate. One thing in particular with the red knot is that the harvesting of horseshoe crabs in Virginia is totally unregulated, essentially. And it's you think, what do you do with a horseshoe crab? Well, in fact, in some of the fisheries, like crab fishery or conch fisheries, they're used as bait. And so there's no thought about how many of these horseshoe crabs we should be harvesting for bait and not letting them have eggs that are going to keep along this flyway of the red knot. So this is, I would part of this, it's not the same as mismanagement, it's unmanagement of an essential part of an ecosystem. Uh, I've got to mention other things like pollution in the ocean. With part of the evidence for a crisis is pollution. Plastics is a really a big part of this. There are 5 million tons of plastic. Over 50,000 pieces of plastic enter the ocean every year. There are islands in the Central Pacific, and now there are islands that have been discovered in the central gyres of the Atlantic Ocean that are the size of the state of Texas. And nobody knows how deep it is, but it's all plastic, and plastic can last for decades, depending on the kinds of plastic. Toxic materials are in the ocean. They enter in. Usually it's accidental. And I bring this especially, you all know about Fukushima and the plumes of radioactive materials that have come off, and they have now certainly documented radioactive cesium-137 was in the water that was released to the ocean. That's now getting into the phytoplankton and going all the way up to the tuna fish, and there are radioactive materials that have been documented off of Fukushima in the larger fish. They were shutting down the fishery just recently. A couple of types of fish, like octopus, fisheries have been reopened because they don't have levels. But there was certainly accidental, I would say almost human error was absolutely by building nuclear reactors where there was going to be a tsunami. The other side is a mystery about that there are high levels of mercury inside of larger fish. And you should be aware of this, that the higher levels of mercury are found in tuna fish, that the levels are such that, and we don't know exactly where it's coming from, and some people suspect it's coming from fossil fuel burning. That's not well established. But the fact is that the mercury is there. I'm giving you the data. That if you were a woman of childbearing age, or if you had a child or a grandchild that's under 55 pounds, the child probably should not eat more than 1 6-ounce can of tuna fish per week. Aside from the great benefits of tuna fish, which is the omega-3 fatty acids, the other side is you're elevating your level of mercury to a level that you should be concerned about cognitive processes. And this was a study that the most recent one came out last week, and it was an elegant study of looking at children in the Seychelles Islands and their abilities. And they eat tuna fish all the time. You all know about the grand oil spill of 2010 and the fact that that oil entered into the environment. It was probably, some people suggest, it's the largest accidental oil spill ever. Something that you may not realize, and so we thought about this disaster and how many barrels, 5 million barrels of oil got spilled. That if you took that oil spill and you poured it on the state of Virginia, that's what it would look like. It was a massive spill by any. But think about this. If you look at the amount of oil that gets into the environment, how many times have you walked along a street and seen a shiny spot on the street? A bus or a car dripping oil onto the street. If you totaled all of those up, the National Academy of Sciences came up with a total. It was about equal to that worldwide. Over what period of time? Over a year, per year. The amount of oil entering the environment accidentally is about the same to the greatest oil spill of all time. Now, this doesn't go with the Kuwait purposeful oil spill, which is probably twice as big. Something of consideration, we're thinking about drilling the high Arctic. And as we drill the high Arctic, how do we handle an oil spill where there's ice? We put booms up off of Valdez, the Alaskan oil spill, or around the BP oil spill. But you can't do that with ice. We are totally unprepared for an accident of any kind of magnitude. There was a small one in Prudhoe Bay back in 2006. Can't handle it. How do you deal with an oil spill in the high Arctic? And we are searching for oil. Shell's rig was out there in September. One other kind of pollution that you may not realize is that as we put carbon dioxide in the atmosphere, we are causing increasing amount of carbon dioxide to dissolve in the ocean. Back maybe in grade school, you took a straw and you blew into a glass of water, and you might have seen the pH change. You got more acid. You were forming a material called carbonic acid. This is straightforward physical chemistry. It's not a model. Well, with increasing amounts of carbon dioxide in the atmosphere, since the time some of you were born, the pH of the ocean has dropped 0.1 units. And you say, 0.1 units, who cares? This is what's called a logarithmic scale. It's a power of 10 scale. That means that the ocean's acidity has increased about 30%. Parts of the ocean have increased 30% since the time you were born. 1750, it was probably even a little bit more basic. Here's at the present. In 100 years, it's going to be double, maybe triple the acidity of today's ocean. Does that mean anything? How important is that? Well, there are organisms. Remember I showed you these? They were called coccolithophores. They're shells made out of calcium carbonate. These are the organisms that are feeding the fish and which get eaten by the seals and the whales. This is called acidification of the ocean waters. We see blooms of the coccolithophores. As the ocean becomes more acid, this is what happens to the coccolithophores. They start to dissolve up. It's like an oyster shell in acid, battery acid. It's happening today. When I gave this talk up in Seward, Alaska, there was one of the native Alaskans came up to me and said, you know, for the first time, we see limpets. They harvest limpets for food. We can see through the shell of the limpet because they're so thin. It's happening today. And the Arctic is one of the more principal reasons. Other organisms, these are called foraminifera. They eat the phytoplankton. There are organisms like the baby young of the crabs or lobsters. They have actually calcium carbonate inside of their shells. They are being affected. When you buy soft shell crabs, they don't have the hard mineral matrix to them. It could be that the soft shell crabs are going to be the only form in the future when the ocean becomes too acid. And the truth is, I don't know what we can do about it. The ocean, because we're putting more carbon dioxide in the atmosphere, we're increasing the acidity of the oceans. Unlike the models of global warming, this is physical chemistry. So whole ecosystem effects are going to come in. Because of the calcium carbonate, because of the pollutants, we have corals are at risk. Literally, about a couple of weeks ago, there was a new evaluation of corals worldwide, and it says that 50% of the coral reefs may already be dead. It used to be, about a year ago, the evaluation was at 10%. Now it might be 50%. Think about the coral reefs and the communities that you know that are, these incredibly high productivity, beautiful communities, and maybe 50% of them are already dead. Potential impact of ocean acidification. This is a couple of authors from up at Woods Hole. He said we're talking about literally, potentially many billions of dollars. Things are going to be changing. So we're seeking solutions. This is Time Magazine. I'm sure some of you have read it. The U.S. government is coming in. About the time that I gave this talk in Seward, Alaska, there was this, within the United States territorial limits, they said, we're not going to fish until we know more about it. Okay, that's management. The United States this past winter came out and said that, well, all fish that we use for catch in the territorial limits of the United States, we're going to manage them. We're going to know how many fish are being caught. We're going to manage everything. To me, it's going to be an impossible task. How do you manage every vessel, every fish? And it's going to be very, and even, for your fish that you catch when you go out on a boat, how will they say, oh, you shouldn't be catching those fish? It's going to be very difficult, but that's the plan. And Friday's Washington Post, there it is, Friday's Washington Post. Juliet Alpern had this article, and here's the hope, that through management, careful management, it may not all be gloom and doom, but we need to have that management. Some of you may have seen this. There's a blue revolution going on. There's fish farming increasing. Well, fish farming's been increasing as, it goes back hundreds of years for growing mussels. But fish farming is becoming global. Here's the flat line. There's fish farming. So the increase in the world's population, the increase in our demand for fisheries. Pardon me? I'm almost done. Is this the future? There are downsides. With all the nitrogen coming down the Mississippi River, all the fish farming that's going in here, we're creating huge dead zones in the Gulf of Mexico. Governor of New Jersey doesn't like to hear this, but that's about the size of the dead zone in the Gulf of Mexico, and it's growing. We're living in a time of unprecedented change. We need leadership, we need international cooperation, and there's a real requirement for management. The changing of the ocean is already going on. Is it in crisis? 71% of the Earth's surface. We've never really cared about what we do to the ocean. It's always been this immense reservoir of food. You could take what you wanted, put anything into the ocean, it would disappear. Few cared. It's only been recently that we have become aware of what kind of damage is going on, what kind of damage, what kind of impact we could have. Thank you. Questions? Are there questions? Please.
Sorry.
Okay.
Why is it that Japan, which seems to get most of its protein from the ocean, seems to be the most reticent about managing that very resource?
I don't know the politics of Japan very well, but I think there's always, as in the United States, we have a balance between the economics, can we get more fish, can we get more resources, versus the people that are controlling that management. And I suspect it probably has something to do with that the people that want to access the greater resources say, let's go and find other locations. I really can't answer that particular one, but I suspect it's like that.
You've emphasized the need for governmental.
I'm looking for where you are.
I'm sorry, I'm here. For governmental, national, international management. But what are things that we can do on a personal level? When I'm talking to my 9-year-old daughter and saying there are things we can do at home, are there things, or are we just making so little dent? What is your opinion?
Well, there's a couple of things, and I'm sorry because I actually had a slide there, and somehow it got into the hide this slide. And I have a list of 10 things. If you want to go to a site and look this up, Oceana has a great site. One is vote, okay? Vote for responsible management. But there are things you, on a personal basis, you can consume less energy. You could eat sustainable fish. In fact, there's a great thing, and I brought along a few, and it was inside of that. You can go to the Monterey Bay Aquarium, and this is a card. You can have one of these if you'd like. And you can carry it around in your wallet. Which fish should you order on the menu? I actually have gone to fish places in Washington, D.C., and I've given these to the people owning the restaurant, saying, and if you don't know, you say, well, cod's on the menu, okay? Cod, is it the North Pacific cod that has, or is it the Atlantic cod? What you should be eating. If you don't know, ask the restaurant, and if they don't know, don't order it, okay? That would be, okay? Yeah, you can download. Yeah, so you can put this could be on your iPhone if you don't want to carry around a piece of paper in your wallet. Okay, so certainly they're up here if you'd like one, or I can help you find it. Energy, fisheries, voting, pollute. Use recyclable plastics so it doesn't get into the ocean. If you go to the beach and you see plastics on the beach, take it home with you. Pick it up. Because it's simply that plastic won't go into the ocean. So there's this whole list of there are things, and Oceana has a very nice thing. Think about disposal of waste. I change oil in my car. What do I do with it? Well, my father had this place in the backyard that says, kids, I'm going to put the oil here. Don't play there. Of course, we always played there, okay? But, where do you take it? Advanced Auto, they have recycling. Recycle these materials so they don't go into the watershed and they don't get into the ocean. There are lots of things like that. Use fluorescent lights, maybe. I've got mixed feelings about it because they've got mercury in them, And what are we going to do with the fluorescent lights? Well, you have to make sure you recycle it. You don't throw it into the trash. So there are lots of things on an individual basis that you can do. One of the other things, though, is write your congressman. One of the things that I actually skipped through is that I talked about the continental shelf within the United States manages the fisheries within the limits. There is a law, it's called the Law of the Sea, that is written by the United States Commission on the Law of the Sea. And it was voted on, passed, brought back to the countries of the world. And it's in place now. But there is one country on the planet that has not signed on to the Law of the Sea ever since the days of Reagan. I'll let you guess. You're already shaking your heads. And this is very controversial, and it's totally in error. Oh, and about trying to get the Law of the Sea, the United States, to become part of the Law of the Sea with the management of the fisheries. A huge, half the world's ocean doesn't fall under a law. And this would improve that. And something even as simple, here's another thing that on my list, tell a friend about what you've heard. We have to teach each other about the management of the ocean.
Would you comment, please, on the proper management of the menhaden fishery in the Chesapeake Bay?
I'm actually involved with some research on that. I work with some people from VCU. And it's mixed, and I would say that some of the data is out. Menhaden are declining, and we don't know exactly why. It might be overfishing, it might be pollutants, it might be the loss of primary production. And in fact, one of the things that has come up is also perhaps the increasing numbers of birds that are in the Chesapeake. They eat a lot of young menhaden. And there are birds now in great numbers in the Chesapeake. There are more eagles around the Chesapeake Bay than I think there has ever been. And so, I can comment that says that, well, they're in decline. I'd say that there is still significant research, and there's controversy about overfishing of the menhaden. The second largest fishery in the United States is in Reedville, Virginia.
Is there no regulation on the catch?
There are attempts at some regulation, but think about the menhaden. The problem with the Chesapeake Bay and the Chesapeake Bay watershed is that there isn't one state that's involved, so it has to be almost federal. You can regulate the crab fishery. Crabs don't, they don't go to the football games and say, I'm a terrapin or a cavalier. They don't care, and they cross over the borders. And we've got a big city that commonly pollutes the bay. Every time it heavy rains, the city of Washington dumps raw sewage into the Chesapeake Bay. So it's not a simple story about the menhaden. I wish it were. These are all complicated. It's one fishery, but it's how many states?
It's one
so it's
company.
Not. I'm sorry.
It's one company. It's omega-3. It's one company. Why can't you regulate them?
Well,
it's one company.
But this is, okay, in the United States, do you have one company being regulated by the state of Virginia, and does that not allow them to fish in the state of Maryland? It's not a simple story.
You were mentioning global warming and coastal flooding, and I spent a fair bit of time in Louisiana. This is a complex situation. Apparently, there's something else coming into play called subsidence, where a great deal of oil is pumped out of the ground and the sea bottom actually sinks, flooding the area. So they lose about 25 square miles a year of marsh in that area. So there are more things that come into play.
And again, there's a pretty good book. It's called Bayou Farewell. Have you seen that? I think Tidwell is the author, and it's all about the loss of the marshes. And one of the questions, and you addressed this, is that we have subsidence. The city of New Orleans is already below sea level. Should we be rebuilding cities that are devastated by hurricane events? Again, another book, if you're interested in, it's called Cool It, and it's about addressing the future. It's not, let's keep on doing the same thing, but we address the future and prepare for sea level rise. I'm sorry, there was a question here?
I think your argument is somewhat compelling about the fisheries being in crisis, but is the fishery strong indicator of the ocean as a whole. I would wonder what your reaction would be to whether this is a good indicator of the health of the oceans, or whether it's much more complex than that because of all the biological activity and geological activity and everything else that's having an impact. You asked us to consider that question about whether, at the end of your talk, whether we would conclude that the oceans are in crisis, and I just don't think that I can do that at this point.
Okay, I would agree with you that all the information is not there. Fisheries are one example. I think fisheries are what touches 1 billion people as far as nutrition on average. So the fisheries are one example. I could also, and there was a limit. This was supposed to be a 2-part seminar, and then an hour now, an hour after lunch. but ocean salinities are changing. There's a lot that has to do with production of the ocean. And so how would you define health? And whether the health is the fisheries and the ecosystems, or is it the total package? Is it the amount of oxygen? I like oxygen. How much oxygen will the primary producers like coccolithophores be diminished so that they no longer supply that oxygen? A good friend of mine, maybe people know him, Grant Goodell, who's a geologist in our department. He says, this has gone on with acidification. A long time ago, the ocean was more acid. Because there will be some phytoplankton that will take the place of the coccolithophores. Do we want to do that experiment? So it's complicated, and all the information on all aspects of how would you define health, I have not presented. Very good point.
You mentioned that New Orleans was the number 1 city that was sinking in the country. The number 2 city is Norfolk, Virginia. There's no oil wells there, but there is some interesting things going on. Can you comment on that? Our own coast?
That's not, the second highest rate of coastal sea level subsidence is coastal Virginia, right around the mouth of the Chesapeake. And it's a complicated situation. People have published different things about why that is. One of the things that I stumbled across is, there was a meteorite impact there, and some people think it's consolidation, and this is what's going to happen. The truth is, subsidence is happening everywhere. All coastal environments of the United States are being lost to the ocean right now. And it's a different rate of loss that's happening. But it's true. The mouth of the Chesapeake is also being rapidly lost.
One more question.
Yes.
You had showed a slide about the ice coverage in the Arctic, and you previously reported that in 2007 the ice coverage was at its lowest, and then recently that changed. I noticed the years in between 2007 and 2012 had a spike up and then started dropping again. Do you have any speculations as to why in 2007, after 2007, the ice coverage raised?
And again, I'm not the scientist doing those studies. Larry Mayer at the University of New Hampshire is very intimate with that. And I think this has to do simply with just general weather pattern changes year by year. We have to look at long-term averages. And so even off of Antarctica, there's this very similar loss of pieces of ice. Why do they happen in a particular year over another? And I think that gets into what the noise of the weather patterns are, and we have to be looking at longer-term changes. And that's not a very satisfying answer, but I think that's what I'd be comfortable with. Thank you. You've been a wonderful audience. Thank you for coming out today.
I want to thank Steve Macko, and we have a small token of our appreciation on behalf of the Lifetime Learning Program. Thank you, Steve. And if you all are interested in sharing this discussion, we're recording this via podcast, so check our website and we'll have a link to that, and follow us on Facebook and Twitter, and enjoy the game.